I will just show briefly what the plan is to kind of present. I will have a short personal background in the beginning of how I ended up here. I will talk a bit how AI in healthcare is perceived, and what are the problems, and what are, let's say, the pros of using it in healthcare, which is, of course, not just limited to healthcare. And I will show some of the, let's say, examples of how we implemented it, which tools we have already that are powered by AI. And I'll just have a very brief closing words from my side. So let me see the next slide. Like I said, or actually Tim has already introduced to me, I come from Croatia and I've been doing my PhD in the Netherlands. But how I got there was a bit of a story because during my studies, I was mostly working on things that involved signal processing and image processing, but I was lacking the processing part, which could be automatic. So I decided to do a PhD, which kind of combines machine learning AI together with medical imaging. That's how I ended up in the Netherlands. And then I was working on the PhD, which was on topic of cardiovascular disease, which is still the leading cause of death worldwide. But of course, there are some reasons why also I transitioned from academia to healthcare industry. So the reasons why it's really nice to be in academia is because, as we like to say in the office, we were pushing the envelope of science. So we really get to work with the experts and also the clinicians and experts in different machine learning fields and also sometimes with patients. To kind of bring forward the problems and the solutions together that we could kind of make things going forward. Another thing that is really nice is because it is a very international area, so you always meet new people from around the world where there's different complications in healthcare or some other problems. And we were kind of like attacking problems from different angles. So, for example, a same problem of, let's say, cardiovascular disease asked into a statistician, clinician, or an engineer would come up with 3 different solutions because every one of them has a different view. On the same problem. For example, statistician would look on a globally bigger scale. What does that mean for a group? A clinician would be, what does that mean for this individual that is right in front of me? And an engineer would be, which tools can I create to make it work for both of them? And another thing that was also nice working in academia is that you do actually have the access to work with cutting edge technology. So all the papers that come out, you have to be on top of them, you have to read them, you have to review papers. And it is quite rewarding to go through that kind of process. At least it was for me. What I kind of liked in this whole situation was that I didn't really feel like I do have an impact. And that is because the solutions that I have provided during my PhD were also, how to say, not really visible. So a small group of people who were interested in this kind of topic, although it is a huge topic when it comes to cardiovascular disease, most of the people would stop and say, okay, you did make a measurement which is a bit more accurate, we appreciate it, but what does that mean for the patient? How can we treat it? So I wasn't on that side of question answering, and I didn't really know why would anyone be interested in my topic then if I don't offer any more solutions. So the key thing that I was missing is actually to have kind of like a clinical application of the solution that I make. And that is why I joined the healthcare industry, because we do have an access now to almost, I don't know, 2/3 of patients in the world can have immediate impact if you just install another update on the scanner, which is, I think, an amazing feature to have, which I was lacking during the academic life. So how can you perceive an AI in healthcare? So we kind of want to see it more as an artificial assistant, not as a invisible box that solves all your problems and thinks for you and other things. So I will walk you through, let's say, an example which could kind of like show you this. this way of thought. So let's imagine that let's have a person here, John. He wants to exercise, he wants to have a healthy life, but he realizes that every time he exercises, he gets extremely exhausted and he has some chest pain, and he does not know what to do. So as anyone else would probably do, as John would, what do? They go online and look for solutions. So when they go online, they read about all the possible problems that can happen. They type in Google, I have healthcare problem with heart and lack of breathing, and then they get a list of problems. And I guess you guys heard of this joke that if you spend enough time searching for which problem do you have, most likely you end up having the terminal cancer or something similar. So John had kind of situation like that, so he decided to go to his GP for a suggestion and advice what to do. And this doctor has a small portable ultrasound, and he scans the heart of John, and he looks at it and he sees that there are some concerns regarding his health. So he advises him to go see a specialist cardiologist in this case, to see what actually could be the problem. So John goes to a cardiologist. She uses a different kind of scanner, a bit bigger, and she takes a couple of measurements, looks at the images, and she says that she's suspecting that there's going to be some congestive heart failure, and that John needs a cardiac resynchronization therapy. Basically, his heart is pumping in inadequate way, so it's not relaxing enough. It is having half a beat instead of a full beat. So it would be good to install a pacemaker which can then resynchronize the heart to a proper heartbeat. And so John goes to an operation, and then he has his pacemaker, and then when he wants to do some exercises, the pacemaker kicks in, and then he is fully functioning, and he's super happy about his new way of life. Now the question is probably that you're wondering, where does the AI come from, or where does the AI come in at the moment? So the first contact John had with the AI was when he went on, let's say, Google, and he searched on what the conditions he has and what he can kind of find on the solutions. The second time he had interaction with an AI was with his GP, which used a portable ultrasound scanner, which has certain tools and imaging techniques that are allowing a GP who is maybe not a full cardiac specialist to still perform the exam to an extent to guide John further to an expert. The third time John had the contact with AI was with the cardiologist or a sonographer who has seen the images, he has used the tools, and he has given his own decision in terms of what should be done further. And the last one can be the pacemaker itself, which is designed to automatically, let's call it that way, predict what are the moves that John is going to do, and based on those, let's say, physical activities, it can continuously learn from and adapt to the heartbeats accordingly. So you can see the AI already can be seen in many places. It's not a new thing, and it has been helping a lot of people with their daily lives. But of course, the problem is that the whole technology does not come for free in a way. There are quite a lot of hurdles, and I will just try to pinpoint some of them that I find the most common problems that I have met over my PhD time, and also within the healthcare, when it comes to the feedback from, let's say, other people who are a bit more skeptical towards AI. The first one that I've heard many times is that AI is a black box. You cannot understand it. It's unknown what is happening. You cannot control it. It's just a random thing. And it's not really that black and white. Another thing that I also noticed that a lot of clinicians have used scanners like CTs and MRIs, but we're not being able to explain me completely how, for example, an MRI works. What is the case space? What is the Fourier transform? But they're still using the technology because it has been a tool that has helped them to visualize so many things and solve so many problems. Another topic is also the statistic models and other tools that are being used in clinics. I rarely found a very good explanation from a clinician what tool is he using and why. And I don't see that much of a difference between an AI toolbox compared to a Wilcoxon sign rank test, for example. Also, it is not impossible to go into the AI solution and kind of see what is the reason why AI has given certain result as a result. And I think the key difference here is that usually when we are making solutions, we tailor them according to our data. But when you're working with AI, you kind of have to flip the problem around and realize that the data is shaping your solution. And that is, I think, which kind of gives this feedback of, I'm not sure how this is all working, but actually it's not that black and white to a black box, let's call it that way. The second biggest thing that I've heard many times is that the jobs of clinical experts will be removed because of AI. And that is definitely hardly ever going to be a scenario. And I think Michael Brady, professor at Oncology Imaging, University of Oxford, has put in it quite nicely, that combining the AI imaging together with radiologists has given a lot better and outperformed any of the AIs or the radiologists by themselves. So the technology supports the decision and amplifies the performance of radiologists. It does not replace them. We would not be here with AI if we did not have the radiologists. And at the end, we understand that we are all human and we want to hear rather a advice from our doctors than going online and looking for a solution ourselves. And there is also another thing that people like to say, that AI really needs a lot of data to train, a ton of data to train, and that is kind of true and not true again. And the reason for that is that it is a very problem specific, the amount of data that you need. For example, a segmentation problem will not require tens of thousands of images. If you are doing, for example, classification problem, you will need a certain amount of images. And also what is actually more important, it's not about the data itself, it's about having the good quality data. So when it comes to annotations and the measurements, the AI can mostly, what it's being taught is to replicate human interaction. And if we go in that direction and we feed the algorithms with poor labeled data, then we are going to get the poor quality results outside. That's simply how it is. And maybe I can now focus a bit more about this taking over the jobs, because I think there's something that we can all relate to. So I'll just give you a personal story of a trip that I did some time ago. So I was on a holidays in Croatia, in Dubrovnik, and I wanted to go to Mostar because I've never been. And our plan, it was the similar probably to 99% of people nowadays. We took Google Maps, we took where we are, we wanted to go to Mostar, and we said, okay, Google, give me a location. Where should I go? And maybe you can see now there are like three options. There's the shortest, the mid one, and the longest one. And of course, we went for the shortest one. What else would you go for? We're going to say 5 minutes. It's going to be fine. We don't need to ask anyone for advice. We just go for it because it should work. And then somewhere close to this red mark at the bottom right corner, we stopped at the road which looked similar to this, which did not really give us a lot of confidence that we are on the right track. But the Google was quite convinced, and we were like, yes, Google should know. We know that we've used it to get here anyway, so it should be eventually there. We are a bit slower than what Google has predicted, but let's say we don't trust that side of Google. And the road kind of became a bit narrow, so we just continued on driving. So somewhere around here, at the second red cross, we found roads which were getting a bit more narrower. The bushes were a bit more wider and scratching a bit on the car. The asphalt got a bit thinner, so we were a bit worried because it's been more than an hour and a half and we haven't really passed more than a half-hour trip. But we kept going to the last point where we decided to be a good reason to return, because we kind of thought that this is not really the right, let's say, the main road from Dubrovnik to Mostar. And this is where you can see this problem of AI without the human interaction. We then returned back and we called our host that we were staying in Dubrovnik. We asked him, okay, what would be the best way to go to Dubrovnik? We followed the GPS, it just got us nowhere. And he just laughed and he said, you know what, just take the second option on the Google and it's perfect. Just go there and you're fine. So even though he knows the road, he knows that it's a lot easier to just give us an advice on the, let's say, solutions provided by Google and just made our life so much easier. We could have saved 3 hours of our time just by asking a person. So this is one of the reasons that I think personally we are not going to lose experts in a clinical setting when it comes to decision making. We're just going to have AI as a great assistant tool and a predictor that's going to help them give a bit more solutions for treating the patients. I will just add a bit more about the hurdles that I came from my own perspective, not from the outside. And one of them is the data bias. I think this is the most common thing that I've seen in the development of AI that has popped as an unexpected turn of events. And that is because people do not have always the ability, or they don't think about all the aspects data has and their associations between them and how do they interact. There was several different, let's say, AI failures when it comes to, for example, hiring processes with AI, or deciding who is guilty or not based on AI, and this kind of things. So there were companies that came up with the solutions like that. They were very biased. For example, there was a situation in the States where the algorithm was trained on the population which was only in prisons, and based on that they decided if the person would be guilty or not, if they just took a picture of the person. And as you can imagine, that was not really enough, and that was extremely biased towards only people who are in prison. It does not tell you that just because you look like a person from a prison that you are a criminal and similar stuff. So these are the things that can ruin completely the accuracy what is reported by AI solution. Another problem that can be overwhelming is the fact that the concepts of evolving the AI solutions that come out on a daily basis globally, it is an immense problem to, I think, to grasp and to filter out which approaches make sense. With a lot of papers on archive and, for example, in the public domain which are published, it is very difficult to scrape through all of them and find the solutions that actually make sense and staying up to date with the cutting edge technologies that are out there. And the last thing is that I think I've met many companies that have thought to have a really good solution. So they, for example, transition from academia to a startup, and they say, you know what, we have a really good idea. We have an amazing tool that we're going to use to save lives. And then they forgot that they have to go through the regulatory aspects. The problem with the general healthcare is it is extremely well-regulated field, which maybe is a problem, but also it is a good thing, I would say, because we want to have good feeling that we are being taken in good hands that we are doing, and that regulator is taking care of the possible misinformation or some other problems, like, for example, biases and other things. So I think it is important to start planning your projects when you're doing AI and similar things, to design it with the regulatories in your mind from the day one. And you can think of it as a very similar to academic peer review system. It is a bit different, of course. There's a bit more paperwork to do it, but you do have another person on the other side, and they do have requirements, and you don't come out of the blue with the requirements. It's usually very well organized, and you can understand which things you need to have in the beginning in order to prove that your tools that you are having are what they are, what you're saying that they are doing. So maybe I can now top off on the good side of the AI. So there was a survey which was done in collaboration with MIT Technology Review and GE, and they surveyed around 908 professional workers in healthcare, And basically, the idea was to kind of get the feeling, what do they have, what are their opinions on AI? How does it impact their businesses? How does it impact their patients? How does it impact their staff and other aspects? And this was performed in roughly 2 years ago. But I will just give you just a small overview, and you can just imagine that these things have been scaled up since then. But for example, the percentage of healthcare that has kind of like plans to develop AI application algorithms have been 74%, and only 13% were not sure, and 13% were kind of like not having current plans to do that. You can see that the number of staff that were planned to be hired was almost 10 people. So between 5 and 9 people was like half of the respondents. And the reason for that is actually the next slide that I will show you, and that is that the personnel that was having, let's say, some sort of AI empowered medical staff, and also some of the tools that were supporting the AI or that were infused with AI, they spend more time performing procedures versus the boring administrative and other work. There is a lot of reports that you need to do. There's a lot of things that you need to do when you're making the measurements. And when you can automate a lot of these things and reports, then you do have times for other things. Some people even said that who have an extensive AI rollouts that even 70% of the staff experienced the positive time done on extra stuff that they actually want to do. And this is also the thing which kind of goes hand in hand, AI and medical field, is that it allowed almost 40% of personnel to actually lead and mentor junior staff, because they did have now the time to drop the parts which were boring, which were necessary but had to be done. But if they can be automated, they had extra time that they can then lead the mentor the junior staff. And another thing is that almost 30% of people feel that they can attract new patients and meet with their families. This is a key problem that, for example, happens in the United States, but it's also coming in other parts of the world, is that the burnout of the medical staff who have the experience and are really good at what they're doing is because the amount of patients is growing, but they just do not have the time to connect. They don't have the time more than just do the procedures. And therefore, having an AI that can kind of cut these times is the way to go. It would be a lot easier if you would have a doctor which you can talk to about your problems, than that the person comes and says, okay, sit down, I do the measurement, thank you, I will send you an email later on, I don't have the time now. That's something that we want to avoid, and we want to push the AI to solve these problems where all of these things can be automated and make the connections between the medical staff and the patients a lot closer. I think I've talked a lot now about the topics of the outside of the company. I can give you a bit more of the overview of how do we actually do the AI within our company. We have had it so I joined the GE roughly 3 years ago, and since then we have been scaling up and building our AI infrastructure and other things. So I will just go in that direction. So the first step that we do, we have a database where we store our patient information, which is anonymized. We do have images, but we do not know who these people are, because we are depending on the contracts and the other legal compliances, depends on what we can do. We have all the images, and then for certain problems, we do some pre-processing, we annotate the images, so we have clinical experts that help us to define the problem to an extent that we can solve it. We can have the measurements, we have the segmentations, we have the generating images. There are many different topics that we're working on. But we also don't work alone. We do have our research partners as well. So we do follow up with them, and we support them in development, and also they support us with certain solutions. So we do have different platforms that we are developing things. So if one of the research partners or collaborators is using a different technology, then we try to find a solution how we can translate the problems or the platforms or the toolkits into common ones. If we cannot, then we just use what we can, because we need to be flexible, because as I said, it is quite an evolving field, and things are changing rapidly, and it's hard to say that you can just sit down and relax and wait for things to happen. And after we have trained and we checked how the algorithms is going, we do have the final steps of the processing, then the integrations on the scanners. So we either convert the models depending on the hardware that they're having, and also we do the final verification steps and other things. And I guess if you are, for example, in the company, or you are developing your own algorithm, you do have a very similar overview on things. You might not have the integration part at the end, but you do have some post-processing, you have some training, pre-processing, annotation, and you have some images in the database. And this is the workflow that you usually would use. There is, however, another thing in the company. This is something that I've been hiding from you, and that's nothing that everybody sees as a thing that they love to do, and that is, of course, documentation. So when it comes to, let's say, a patient data and other information, there has to be a certain agreement, the legal compliances for data collections. We are not allowed to, of course, just use the data just because we got it, or we've seen it, or we found a hard disk with some data. That is not how things work, and we need to have for audits and all the other things, we need to have all the documentations ready. When it comes to annotations, we need to make sure that our solution that we are trying to make as an AI solution, for example, that they follow the guidelines that are given by for example, American Society of Cardiology and other important clinical healthcare impacts. And basically, the idea is that we can, of course, come up with our own solutions, but it is not. It is going to take a lot of time to explain why is this the way of doing things and not the way that everybody is doing it. When it comes to training our algorithms, we have to make sure that the performance is adequate. We look into, of course, the academic peer-reviewed articles. We look into competition. We look at what are the places on the clinical side, the clinical sites that give us, for example, feedback on certain aspects, how we can improve, and we have to all document that and follow up on these things. And then the last thing actually is the whole wrapping up of the process, filing for the FDA, which is basically containing all the steps before. You do have to have the requirements, which, for example, different countries have different regulators. So there's FDA in the States, there is a CE mark in Europe, there is NMPA in China, there's one in Australia, Canada. So there's a lot of different requirements we need to kind of follow up and prepare documentations that are ready for that, to also have our claims adjusted accordingly, and that we do not say things that are not really true. So in a way, if you're in academia, you would find this very similar to academic paper. It might be just a bit more rigid and more open in a way. So I will try to show you a video now of one of the solutions. I will try to pause and play, but if it doesn't work, I will just explain in a slide afterwards. So it's one of the measurements, I think. Oh yeah, the pause and break works great. So you can see here one of our scanners and an image on top, which is the personal long axis view. Probably doesn't mean a lot, but it's not really important. The important thing is that we made a tool which is supposed to make a measurement automatically instead of person doing the process of labeling. And this whole process requires certain steps, and we try to minimize the interaction of the person who is using the scanner to minimum. And this is how, for example, this image looks like. At the bottom you have the ECG signal, which is kind of showing you where the heartbeat is happening, and in the middle you can see the mitral valves opening and closing, and this is how the automatic tool looks like, and you can see it kind of just like happened. like that. In a way, we reduce the number of clicks that people are using up to 80%. Because of the following situation, the person needs to click a lot of things on their own. They need to scroll, look back and forth, and they need to spend a lot of time on a certain image, right? Instead of actually doing it automatically. Maybe I can just skip this other part of the video and show you actually the workflow, how it looks like. So like I said, the person goes to a clinician, they take the probe, they find the diastolic frame, they measure the septum, then they measure the internal diameter, then the posterior wall, then they have to click to go to another view to select the systolic frame, then take another measurement, and then do the measurement of the internal diameter, and then basically everything else is calculated automatically. With an AI tool, basically it looks like this. You click auto measure button and it's there. It just does everything by itself. And here you can see the time that can be saved when a person is doing things. So if you go to a clinician and the clinician says, you see, this measurement has been performed right now, you can take a look with me and you see your personal wall is a bit thick here, or there are some other problems, or there is no problem. Or for example, another thing that a clinician can do, it can adjust their own the measurements. It is not made that the AI is perfect and it's set in stone whatever it gives, but with a certain accuracy that we report, clinicians do get used to what an AI can do, and then they can judge themselves. Oh, this makes sense. This doesn't make sense. Of course, depending on the expertise of a certain clinician, it can be that they are more or less experienced in a certain field, and therefore the AI can help them into refreshing their memory or showing them the solutions that they can do. And this is where we want to actually have this extra time that is given to the patient itself. I do have another video, I think, which is going to be a bit different. So I will try to pause it in a different way. There's some music in the background, but it doesn't really matter. So what we made is an AI auto measurement tool for the spectrum recognition. So basically a certain measurement is performed on a patient where you are looking at the echo of the spectrum on what is happening with the heartbeat. If there's some noise, if there is a good heartbeat or not. And the person needs to highlight a certain number of these pillars that can be done with a single click, basically. And as you can see on the right, there is a button which says approve without changes to store. And that is something that we always want to give to a clinician. We want to have them the ability to not just use it blindly and say, oh, this is how it should be, and you just take the road from Dubrovnik to Mostar as the Google has suggested. But no, you actually need a person who can say, oh, I think this makes sense or this does not make sense, and we don't want to hurt the patient or anything in any way because of the tool itself. I think in this video you can also see some other tools. So basically, depending in which view the image was acquired and it is being acquired, the tool itself is adjusting which automatic measurement should it invoke. And then it plots the results immediately, and then the person can change it accordingly if they want to or not. Otherwise, I think this is the part of the video which shows how it's done manually. You have to click on a certain measurements. Once you have clicked on the measure, you have to go and annotate all by yourself, select the heartbeat, and then you repeat that for another 3 heartbeats because they are the good ones acquired here with the full heartbeat. You can see that even these small things that maybe don't look like they're complicated, everyone could, with a lot of experience, plot these blue lines here. But the time is here what we are aiming for to save and also give more time to patients, have interactions with the clinicians, and make, in a way, the clinical field to be more human. As it says here, your time is precious, we want to save it. So I think I've talked enough about this tool, but basically, as I said, the upper row would show you how you have to click many times to select the right measurement. And it's not a problem, of course, but you have to think about the person who is doing these scans. He has to check 20 people in next hour, and it needs to go really quickly and rapidly, and they don't have the time to think if it's good or not. They need to quickly find all the buttons and click. And if you do it automatically, you can fit 20 people in an hour and still have a word with them. You can explain them, look, I think this is the problem, or you are perfectly fine. You see on this image, and I can share you this information. You can later on go online and Google more about it if you feel like I missed something and stuff like that. And I think then people would have even more feeling that they are not just a number at the doctors. So what we also do is we don't do, let's say, AI as a tool itself, just it's one tool AI built. We do, for example, have view recognition, which is AI based, which is supposed to detect which view the image is acquired. So if you're doing an ultrasound scan of the heart, there are different ways that you can visualize the heart. And based on that, there are certain measurements that you can perform. And certain conditions can be detected and diagnosis can be done. Therefore, we have it, let's say, an AI-based tool, which is then infused in other tools that are, let's say, classical tools where there's normal image processing or some other techniques that we can do the measurements a lot more accurately. And with this, we can filter out all the images that are maybe not adequately enough made, that some tissue is missing. And we noticed that the detectability of our algorithm was 98%, which was extremely good. And the feedback we got from the clinicians was also very welcoming. Just another thing on the spectrum recognition thing that I used. So if you think about 98% of keystrokes less, that's quite a lot. And another thing that we are aiming to solve is the operator variability. The good thing about the AI is that it is going to give us the same result on the same image over and over again. If you work with the people who are super exhausted at work from work and doing all the clinical stuff, and then they need to quickly look at some images, they might have different opinions when you ask them in the morning or in the evening. And this is where AI is also proven to be quite good. Of course, there is a downside. If the AI is wrong, it's going to be wrong all the time. But that is why we want to have the human in the loop. And this is mostly this is the key thing to have in mind. And I think I can just leave a bit more now at the end with some of the closing words. And again, I did pull a quote from a person. So it's Matthias Merkel from University of Oregon Health and Science University. He put it really nicely. He said that we need to evolve and understand how AI can work for us. So we can interpret the patient's health and conditions, give them a good recommendations, and also, which is really important, is the longitudinal process. We have had a lot of problems having a longitudinal access to people and also having the right measurements being performed over time because of, for example, as I mentioned previously, the people do get tired. Machines don't really get too tired. Therefore, it is quite important to have very good measurements over time in order to have a really good predictions and also to provide a better healthcare in the end for the patient. And I think this is the way that we can make our healthcare more human again. I personally have not had the experience with the doctors that they did not have the time for me, but I have had a lot of communications with the doctors around the world, and this was one of the key problems that they really have. They feel like the patients feel like they are just numbers, and they don't want that. They want to change that. They want to help people, and they want to be, as they say, part of community and everything. So I think I will stop here.
But I have a question for you, Jurica, while we wait for that, because I was interested in what you said towards the early on in your talk about the criticism about AI being a black box.
Mm-hmm.
And I think you have a good point that a lot of the time end users do not really understand the technology anyway, so it doesn't really matter what in which way that box is black. But here's the thing. wouldn't you say that in some cases the lack of transparency for our modern AI methods, because of complexity, not because it's a black box per se, but because of complexity, even the developers do not understand the relationship between the inputs and the outputs. While for a Fourier transform or something of that nature that you also mentioned, the developers will be able to understand the relationships going on, while that might not be true for the AI. And what would that mean for the development of the products?
So I completely agree with you. I think the lack of transparency is there. And there are different approaches within the AI that are trying to, for example, highlight how has the network, for example, of the convolutional network came up with a certain solution. So if you look at the gradient descents, how they're happening, and then you try to look back on how the weights of the network has been changed. What if you reshuffle them? What does it mean? Does the network generalize well? I think there are ways to do that, and I think a lot of people are interested in working on these topics, and I think there's plenty of papers that are published in this field as well. I think I've read the paper from a couple of months ago, which was basically comparing several different approaches of showing what are the reasons of how AI has came up with a certain classification result. And definitely that is something that I personally, as someone who is also working in this field, would like to see. And when I'm designing my own algorithms, it is a bit, of course, difficult as soon as you make an extremely complex problem, because it takes a lot of time to develop into small parts of, okay, now this happened, and then I went this, and this is happening. But for sure, there are ways to show and also let's say, make it more transparent of how has some decisions been made. There are also parts of the solutions that are not fully automatic, made by AI. The pre-processing and post-processing parts should for sure be, for example, something that you can show to a user and show, okay, so the AI thought that this would be the measurements, and we know that these shouldn't be, so we filtered out and showed this to a user. And I think every clinician that I've talked to has said the same as you did. I would like to see what is happening in the background. And I completely agree with that, and there is something that we are working on.
Thanks. We have a question here from Kerstin Bach, and she's starting saying, thanks for the nice talk. I'm wondering whether the support and AI gives to the clinician will lead to the fact that clinicians develop less expertise to actually analyze ultrasound images by themselves.
I have to admit that is a risk, and I think that is quite good to know the risk before we start introducing these things. But the thing is that we also we got the feeling like technology has made us, let's put it in a way, maybe dumber in a way. But I think that the fact that we cannot develop the tools without these experts is the reason why we will always need them. Of course, I can gather certain experience over time in certain measurement, in certain cardiac problems, but a clinician who has seen 200,000 patients more than I ever will, probably is the person that we want to cherish and we want to keep, and we want to have this person teach and share this knowledge. And I think this person cannot share the knowledge with me as a developer in a way that it can to a wider audience, such as a clinical team or let's say doctors in general. So I think this is why, in a way, it's good point to have it in mind and to keep that thing ongoing. I don't think it would happen like it can happen in other fields, where you're trying to automate the problems that are, let's say, not mentally as challenging. For example, if you have an autopilot in a car and you don't want to drive, it's perfect for you. But if you want to have a diagnostic and follow up on longitudinal progression of your disease, I think you would rather want to have someone who has tools and measurements that are really accurate, but then the decisions are made based on the best experience that the people actually have.
I'm interested. You mentioned. I think you kind of agreed with yourself finally that it's not a problem that the healthcare area is a well-regulated area. It's absolutely a benefit. Could you say a few words about first of all, are those methods, are the sort of the assurance frameworks good enough? And if they are, do you think there are other application areas that could learn from what's being done in the healthcare domain?
Well, I think because it is a well-regulated area, it is always evolving. So we have experienced throughout our development that, for example, certain things have gotten stricter and stricter and stricter, and they're all, in my opinion, have been done in a way that actually it should be. So, for example, the amount of data and the amount of things that you need to report to make a generalized claim has increased, and sometimes it's let's say a reasonable request. Sometimes it is not. But I think it is good to have it, and I would not want to reduce it. And I think other fields who have regulatories do learn from each other on a daily basis. And I think, for example, the road or the traffic industry has kind of had the feeling that they have to learn a lot from, let's say, healthcare when it comes to automated driving and similar stuff, because it is a very similar approach of where does, in the end, the responsibility come from? Does the responsibility come on the AI tool itself, or the clinician that has used the tool, or who is the responsible person? And in order to make it clear, you also need to make it clear who is making the claims and what are the claims. And that's why the regulators have been quite strict. And I think it has always been good that they are strict. And the nice thing is when you work with them over time is that you learn that they are not your enemy, and if you contact them early enough, it's rather straightforward approach. They tell you, okay, we will need this and this from you because in order to claim these are the requirements, and then you just go with that. And that's actually what I thought it would be a lot more challenging, because I thought that you make everything and it's like in a peer-reviewed journal, you submit it to a review and you hope for the best. It's like you actually have a reviewer on your side who's saying, you know what, if you want this out, you need to make sure that these things are covered.
Yeah, I think that's a good point, and I have the same experience in different fields. You can work together with these notified bodies. There's another question here. I think it's sort of somewhat along the same lines. It's from Gunhild Paulsen, and she asks, does the implementation of AI in your medical devices create issues during the regulatory clearance process? And are the global regulatory agencies well equipped to review AI devices?
So there is a bigger burden when it comes to AI, when it comes to regulatories. It's a lot more challenging to clear out an AI solution compared to, let's say, a normal tool or measurement, a new probe and stuff like that. And I think that has been because of the fact that there has been a lot of claims coming from different companies who have a very strong claims when it comes to generalizing the problems, and then a certain bias pops out and then it's all ruined. And basically this is where I think all the regulators globally have learned a lot. And even though they are quite different among which requirements they do have, they all do want the same thing, and that is the safety of the patient. It has been maybe sometimes that the regulators have asked too much, in our opinion. But I personally would rather have that someone asked me too much than too little. And I think with this pandemic, there has been a lot of questions coming from the regulators and how is this all cleared and everything. And personally, when I've been working with the regulators, it has felt like it is never a piece of cake, and it is something that is taken really seriously. So I'm always feeling quite assured what comes out as a cleared product, as from a global perspective, or let's say regional FDA and stuff like that, that you can trust what is happening.
Very good. I think we're approaching the end here, but maybe a final question from my side. If you could also say a few words about research partnerships. So I suppose you in GE also are working with researchers outside of the company. So maybe comment on that.
Sure. So we do have, for example, projects which are in collaboration, not just in Norway. So we have plenty of them within Norway. There's a good connections with the NTNU and also university, but we also have partners, for example, in the Netherlands, in Belgium, and globally. I'm just talking about our part, for example, the ultrasound business. So we want to actually have the research close by because we know how much they can actually give and how much of motivation they have to actually push the things when it comes to from a paper to a solution. And we do know that it is quite a challenge later on to clear the regulatories, but we know that also the peer review papers are not easy to publish. So we try to help them in that sense, and also we are having certain PhD students within our company who are hired from the grants that we have gotten together with some universities and stuff like that. So we do have a quite close relationship with the research, and I think it has been going quite well, and we are all continuing and growing these collaborations. And also it is a good source of finding people who think that maybe academia is not the way to go for them. At least for me, that was the case, and I'm welcome to welcome all the people who think that they share the same passion in this solving the problems with the super cool tools and fun stuff, and also actually having an impact.
Very well, thanks a lot, Jurica. I don't think we have more questions from the audience, but that's fine. We are almost close to the weekend. So thanks a lot for taking the time to give us your perspectives, and thanks to everyone who joined the webinar as the audience.